Hello friends, myself Pratik. In this session we are going to discuss K nearest neighbor classifier. K nearest neighbor is commonly known as KNN classifier. And in order to understand its working principle, we are going to consider the same dataset that we used during naive-based classifier. Here we have collected the data of employees of an organization. We labeled this data in two classes. One, employees who commute to the office on four-wheeler and another who commute on two-wheeler. We have labeled this dataset on the basis of age and salary of the employees. Let us consider this new data point. This is the new employee who joined this company, and we wish to predict whether this person is going to commute on four-wheeler or two-wheeler to the company. And this is the position of the data point based on age and salary of the employee. In order to predict the class of this new data point, we are going to use KNN classifier. KNN classifier actually worked in 4 steps. In first step, we have to choose the number of neighbors to this new data point. And we call these number of neighbors as K. By default, the value of K is considered as 5. But of course, you can change this value depending upon the type of dataset. And in this example, I am going to have the value of K as 5. It means we will be looking for 5 neighbors to this new data point. In step 2, we find out these K neighbors from this new data point on the basis of distance metric. We can use Euclidean distance or Manhattan distance to find out the neighbors from this new data point. Let's quickly discuss Euclidean distance to understand it properly. Euclidean distance is actually considered as a geometric distance between two data points. Let's suppose we have one data point with coordinate value xy, while another data point with coordinate value a and b. We can find out Euclidean distance between these two data points by using this formula. Let's apply this formula on these data points to understand it properly. Here we have data point 1 with x-axis value as 6 while y-axis value as -2. Data point 2 has x value as 9 and y-axis value as 4, and we want to find out the distance between these two data points. So to find out this distance, we can use Euclidean distance, and its formula is x minus a square plus y minus b square under root. So if I fit all these values in this formula, the equation will become like this, and if I solve it, I can get its Euclidean distance. So by using Euclidean distance, we can find out the 5 neighbors to our new data point, and all this process is performed in step 2. In step 3, for each selected neighbor, we have to check its class. And after checking the class of each neighbor, we have to count the number of neighbors in each category or class. It means if we have 5 neighbors, we have to check the class of each neighbor, and after checking the class of these 5 neighbors, we will find the count of number of neighbors in each category. In step 4, we find the category with highest number of neighbors, and that category will be considered as the category of our new data point. So it means simply we will find out 5 neighbors of our new data point, and then we will checking its class. After this, we will find out the number of neighbors in each class, and the winning class will be considered as the predicted class for this new data point. Let us apply this concept on our data set. So let's suppose this x is our new data point. We have to predict its class. So we will be looking for its 5 neighbor based on some distance metric. Then we will find out the count of each of these neighbors which belongs to a particular class. So here these 3 neighbors belong to a class of four-wheeler, while these 2 neighbors belong to class of two-wheeler. So we have majority of neighbors belong to four-wheeler class. So that's why this new data point will be considered or classified as four-wheeler. So this way we can make out the prediction for any new data points based on the category of its neighbor. So the idea is very simple. We have to find out k neighbors of this new data point. We will check the category of these neighbors, and we will go with the majority. If most of the neighbors belong to class A, then the predicted class will be A, otherwise the class will be B. This is all about the working principle of KNN classifier, and in next session we will be implementing this classifier in Python. Thanks for watching this video.